Welcome to this video about rogue planets, and in a previous video I introduced what rogue planets were and one of the key processes that led to their formation or their current configuration, which is basically not orbiting a star. I'm going to go through a alternative formation process in this one, but just to recap on rogue planets to start with, a normal planet normally has a few characteristics to be classified as a planet, and one of those is that it orbits a star. They normally have to be big enough that they're spherical in shape or thereabouts. They also need to be large enough that they gravitationally clear out material in their orbit. But a rogue planet actually doesn't orbit a star. They're not gravitationally bound to any star, so they are sometimes known as free floating planets. So they're moving around in space without being attached to a star. They still get influenced by other things as a star would be moving around, but they're not in an orbit around a star. So this is the key criteria of a rogue planet. So let's start with star formation, because this is then going to relate to this particular process which leads to rogue planets. So stars normally form in these giant molecular gas clouds. This is an example, which is the Orion Nebula, and you can see lots of blue stars in that nebula, and they have formed fairly recently, and they're young, large stars that have collapsed, or the actual gas cloud itself has collapsed locally. You've then got a star form, and this is fairly typical of star formation. So you get these large gas clouds, they gravitationally collapse to the point where they get hot enough in their center to start hydrogen fusion in their core. You then get a star in the main sequence. So that's pretty much how stars form. And in that process, these stars actually have disks around them. So you have these circumstellar disks, or where you would have planets forming. And this is an example of one, an image taken. And when you zoom in, the planet itself actually has a disk around, which is likely forming moons. So we think that the majority of planets form in these disks around young stars. And in the other video, I had a look at that and how they might get ejected from those systems later on. So that's the typical process of star formation, planet formation. That's mostly what we think. However, if you've got a small enough cloud, if it collapses and there's just not enough mass there to form a star, then you can get planetary mass objects instead. So this time around, you'd have a much smaller cloud that is gravitationally collapsing to form a much smaller object. Now, the reason why that doesn't actually produce a star is that there's not enough mass there. So when it gravitationally collapses, it doesn't heat up the central core enough to start hydrogen fusion. So a planet, you don't have that core that's generating energy, whereas a star you do. So that smaller gas cloud just doesn't produce a star. And this is one of the processes that we think may account for some of the rogue planets. Because if you've got a gas cloud that collapses to form a planet, there's no star there to start with, so it never had a star. So some planets will have had a star and they got ejected. Other planets would have just formed on their own and they never orbited a star at all. Now, the same is true for brown dwarfs, actually. So brown dwarfs are kind of in between planets and stars. They're not quite the right core temperature to begin fusion. So again, they're not quite a star, but they're kind of a little bit bigger than a planet. So they're kind of in the boundary area, really. And like I mentioned from the other video, they can also be formed from gravitational scattering. So if you want to check out how the gravitational scattering can produce a rogue planet, then check out the other video on rogue planets. But this is where they have like a close encounter between multiple planets in the system. One of them can get thrown out, and we think the solar system may have done that as well. And then you get a planet that's free floating around in space without a star. So originally these ones would have had a star to orbit. So thank you for watching, and if you enjoy, then check out some of the other videos.